All right, so if you just came in, our aim is how do we graph the cosecant and secant functions? The graph of cosecant is shown here. And part A of the do now is what is the period of the cosecant graph? Meaning how long does it take to complete one cycle of cosecant? And then part B is where does this graph of cosecant have vertical asymptotes? Meaning what are the x coordinates at which they occur? Homework is going to be on a handout, numbers 13 to 16, as well as 19 and 20. Okay. All right, so with that, let me get to the solution. And zoom in. All right, so the period of cosecant is going to be 2 pi. All right, and the way you're going to see that is if you look at one branch here, so like this goes from 0 to pi, right? And then after that, you can recognize that it doesn't continue, right? So it doesn't repeat that that same loop above the x-axis, right? So if there was another loop like this above the x-axis, let's say we had a loop here, right? We could say that the period would be pi. However, it's not like that, right? The next loop is over here, down here, which gives us new values of the cosecant graph, okay? In other words, this is a new part of the graph, which means that is also part of one cycle. So in summary, right, we have 0 to 2 pi. That would be the period of cosecant. Okay, so we would say that the period of cosecant is 2 pi. Okay, and as for part B, where does this graph of cosecant have vertical asymptotes? That would be negative pi, 0, and pi. Right, so as you can see, the dotted blue lines here, negative pi, 0, there's no blue line, but yeah, so, but as you can see, right, the graph of cosecant approaches negative and positive infinity there. And then we also have a vertical asymptote at pi. And the pattern here is that it's going to be multiples of pi, which I'll explain in a sec. But yeah, those would be your two answers for the do now. All right, any questions about this? No? Okay. All right, gonna move on then. All right, so for the rest of the lesson, we're gonna be talking about properties of cosecant and secant, and then draw the cosecant and secant curves. And then after that, just the classwork. Okay, so relatively short lesson. Question.
Yeah, I just had a quick question about why sine and cosine don't have asymptotes, but cosecant and secant do.
Okay, so that just comes from the definitions of cosecant and secant. So cosecant as a reciprocal function is 1 over cosine, right? So vertical asymptotes occur where the denominator can be 0, right? So cosine can be 0, right? Cosine is 0 at pi over 2 and other values. But cosine itself, it can't have a denominator, like it's just adjacent over hypotenuse originally, right? That's the most basic definition. It's the ratio between the adjacent and the hypotenuse side of a right triangle. But the hypotenuse can't be 0, right? Otherwise it wouldn't be a triangle. Okay. So that, yeah, in that case, yeah, cosine wouldn't have a vertical asymptote because the denominator of the ratio can't be 0. Okay. Yeah, good question. Anyone else? Okay. All right, let me move on to the notes. Okay. So this first part, can someone read this part right here? Oh yeah, you can just unmute yourself and start reading.
Properties of cosecant and secant. The functions cosecant and secant have period 2 pi. Cosecant x plus 2 pi is equal to cosecant x, and secant x plus 2 pi is equal to secant x.
All right, very nice. Okay, so as we saw from the do now, right, cosecant has a period of 2 pi, And it would make sense that secant being the reciprocal of cosine also has a period of 2 pi. Okay. And then if you remember from last week, right, tangent and cotangent, those functions have periods of pi. Okay, everything else, all the 4 other trig functions that we see, cosine, sine, secant, cosecant, those have a period of 2 pi. All right, can someone read this part for the cosecant curve?
The cosecant curve has vertical asymptotes at the points where sine x equals 0, i.e. the at x equals n pi, where n is an integer.
All right, thank you for that. So yeah, cosecant, right? Cosecant is 1 over sine. So wherever sine is 0, that will be multiples of pi. Then there's going to be a vertical asymptote. Okay. By the way, this is an abbreviation for, well, actually, let me ask you, is anyone taking Latin here? Does anyone know what this means? You can just speak up. But, all right, well, is anyone taking Latin? No? Oh, okay, all right. Well, anyways, this is an abbreviation for id est. So two words, which means that is, as you know, a direct translation to English. Okay, id est is Latin for that is. Good. Okay. All right. So yeah, that was actually one of my math teachers who taught me that. So remember that from way back when in the 60s. But yeah, so shout outs to him. All right, anyone for the secant curve?
The secant curve has vertical asymptotes at the points where cosine x equals 0, i.e. at x equals pi over 2 plus n pi, where n is an integer.
All right, thank you for that. So secant being the reciprocal of cosine, it's going to have vertical asymptotes where cosine is 0, right? So cosine is 0 at 90 degrees, 270, right? Multiples of, well, not multiples of pi over 2, but pi over 2 plus multiples of pi. Okay, so pi over 2 plus pi would give you 270, etc. All right, does anyone still need these notes? You can speak up. Yeah, okay, well, all right, I see nodding, so, but yeah, just all right. Anyone still need this? No? Okay, I'm gonna move on then. Okay. All right, next part of the graph, we're gonna talk about the curves. So those were the properties of cosecant and secant, right? So cosecant and secant have periods of 2 pi, and you guys know where the asymptotes occur, right, from the last slide. Here we're going to talk about the graphs. So the functions y equals a cosecant kx and a secant kx, given that k is greater than 0, have period 2 pi divided by k. So just like sine and cosine, 2 pi divided by this coefficient here, k. An appropriate interval on which to graph one complete period is 0 to 2 pi over k inclusive. So it's the same as sine and cosine, which is a relief. You don't have to like memorize anything else, right? So tangent and cotangent were different, right? So tangent was negative pi over 2 to pi over 2. Cotangent was 0 to pi. But cosecant and secant are the same as sine and cosine. Okay, so just copy this down, and then after that, we'll get to the graphs themselves of cosecant and secant. Okay, anyone still need this? Please speak up or type something in the chat. No? All right, we'll move on then to the graphs. All right, so cosecant and secant. All right, so to graph cosecant and secant, we're going to use the fact that the reciprocal functions of sine and cosine respectively. So cosecant being the reciprocal of sine, we're going to take the reciprocals of the y-coordinates of the sine graph. Okay, so here's my table, 0 to 2 pi, right? And then here are the y-coordinates for sine, right? So normally for sine, it's 0, 1, 0, negative 1, 0, right? And then for cosecant, right, just take the reciprocal. So 1 divided by whatever this value is, 1 divided by 0 will be, I'm going to write positive, negative infinity here, right? Because as you can see here, there are two branches for the cosecant graph. And this is another way to denote asymptotes. So just write positive, negative infinity here. And then the next coordinate is going to be 1 divided by 1. So that'd just be 1. This is also going to be positive, negative infinity. And then the next coordinate is going to be 1 divided by negative 1, which is negative 1. And then lastly, we have 0 again. So that'll be positive, negative infinity. Okay. And yeah, this is the same graph from the do now from the textbook. Okay, but yeah, so this will be your chart here. And the coordinates that we plot are these, the x coordinates, right, 0 to 2 pi, and these are the y coordinates.
Wait, Mr. Liang, could you explain why there's a positive and negative infinity for cosecant?
Yeah. So like normally for asymptotes, like for the tangent graph, we did either positive or negative infinity. The reason for that being we only saw like one side of the asymptote. But realistically, if you remember from tangent, right, there was another branch on the other side that if you approach that asymptote from the other side, then it would be the other infinity, right? Here, in this case, at least for this graph that's shown in the textbook, we actually see both sides of the cosecant graph, right? So on both sides of 0, so on the left side of 0, the cosecant graph approaches negative infinity. On the right side of the cosecant graph, as you see here, it's positive infinity. Okay, but realistically, we're only going to graph 0 to 2 pi. So I guess we could even just say positive infinity for here for 0, and then positive for, well, for pi we would have to do both because we would show both sides for 0 to 2 pi. But yeah, you can just write positive, negative infinity and not have to think about it, right? So but I'm gonna keep consistent with what the textbook does, so I'll just write positive, negative infinity. right, but yeah, does anyone still need the chart here? Speak up or type in the chat. No, okay, all right. But yeah, there's your graph. So I know the interval that was shown on notes was like 0 to 2 pi, right? But this is what they show in the textbook. So actually, in your notes, I would actually, if you already drew this, it's fine. But just to keep consistent, I actually don't know why they drew this in the textbook, but they did. So 0 to 2 pi would be that, right? So it would be just this branch here and that branch there. Okay, so that's what I would draw in your notes. So 0 to 2 pi, like this branch here and this branch here. Okay. All right, I'm gonna move on. All right, next graph is secant. So secant is 1 over cosine, right? Same thing we're gonna do for part A, right? To just take the reciprocal of the y coordinates for the function, right? So 0 to 2 pi here. For cosine, it's 1, 0, negative 1, 0, 1, as you see here. And then the reciprocal of that would be 1 divided by 1 is 1. Here would be positive, negative, infinity. Here it's negative 1. Here it's positive, negative, infinity again. And here it's 1. Okay, so as you see here, right? So for the points, it will be 0, 1. So that'll be our first point that we plot. I'll draw that here. All right, our next point is at pi over 2, negative infinity. So I'll just draw that dotted blue line here. Next, we have pi negative 1, which is here. And then another asymptote at 3 pi over 2. And then at 2 pi, it's also 1. And again, they didn't go up to 2 pi for the graph in the textbook, but that'll be right here. So technically, it should be like this. Okay. So your graph in your notes should look like what I'm drawing in blue here. Apologize for the fuzziness of the lines, but I'm just using the zoom annotation function. Okay, it kind of looks like a frowny face. But yeah, that's what it looks like for secant from 0 to 2 pi. And actually, I would add a 2 pi here. Yeah, the textbook was not consistent in what they said from 0 to 2 pi. So, but I will be consistent and draw it from 0 to 2 pi. Indeed, Elijah, indeed. All right, anyone still need this? No? Okay. All right, gonna move on. All right, so after that, it was just the textbook, or not the textbook, the classwork questions. So if you wanted to try it on your own, you can come back to this video or like after class, but I'll show you the solutions here just for reference, so you have them. So the first graph was y equals 1/2 cosecant 2x. So here there's a vertical shrink, and there's also a period change. Okay, so the period is 2 pi divided by this coefficient 2 here. So the period is going to be pi. Okay. The x coordinates are the same as sine and cosine, so it's 0 to 2 pi. And next we change the period, or change the x coordinates because there's a period change, right? So divide everything by 2. You get 0, pi over 4, pi over 2, 3 pi over 4, and pi. For the y coordinates for cosecant, it was positive, negative, infinity, 1, plus minus infinity, negative 1, plus minus infinity. Okay. So if that doesn't seem familiar, that's okay, right? This is our first time seeing these coordinates. But yeah, that's what they were from the example, right? Anyway, for the vertical shrink, right, we just multiply by 1/2. So The infinities stay the same, but the 1 and -1, they change to 1/2 and -1/2. Okay, so the coordinates that we plot are 0 to pi, and then these would be the y coordinates. Okay, so 0 to pi, that'll be right here in pink. Okay, so here they're actually graph 0 to pi. Okay, that's good. It's what's in pink here. So at 0, there's an asymptote. At pi over 2, there's another asymptote, as well as at pi. And then at pi over 4, it's 1/2. At 3 pi over 4, it's -1/2. So that'd be your graph for the first classwork question. Eden, what was wrong? Okay, all right. Well, I'm gonna move on to the second classwork question. The second classwork question was 3 secant 1/2 x equals y. Here is gonna be 2 pi divided by 1/2 here, so that'll be 4 pi. Here are the x coordinates for secant. In the next row, we change the coordinates. So we divide by 1/2, or another way to say that is multiply by 2, right? So 0 pi, 2 pi, 3 pi, 4 pi. These are the y coordinates for secant, right? 1 plus or minus infinity, -1 plus or minus infinity, 1. And then here you apply the vertical stretch. So you multiply everything by 3. And these are the coordinates you'll get. Okay, and then here they also thankfully keep consistent with what they said in graphing the interval, right? So 0, 3 is here, and then there's an asymptote at pi. At 2 pi, there's a coordinate of -3, and then 3 pi, there's an asymptote. 4 pi, it's 3. Okay, and then in pink, that's the graph that you should get. Okay, and then we get the iconic frowny face for secant graph, or for the secant graph. Okay, but yeah, that's your solution to question 2 on the classwork. I won't have you guys submit this on Google Classroom because yeah, I'm showing it here. So yeah, tomorrow we'll just go through some cosecant and secant transformations. But yeah, as a reminder, there's SGI today at 2:47 in case you have questions. And another reminder, our next quiz is this Friday. So I posted the topics list over the weekend. So please check that out if you haven't seen it already. But yeah, it'd be 25 minutes. I made it to be 5 questions this time just because the questions take a little longer. But yeah, that'll be this Friday during class. Okay. All right. With that being said, if you have no other questions, you're free to go, and I'll see you all tomorrow. All right. Take care and have a great day.
Have a good day.
Thank you.
Thank you too. Yes, question?
Yes, I have a question. So would it be considered wrong if instead of putting plus and minus infinity, you put what it is for what's it called? For cosecant? You remember how you said how we're going only by the right side? So we would put it
So,
as-
yeah, it wouldn't be wrong. So like, for example, like, yeah, you could be consistent with it. So for example, for this graph at pi, right? At pi, we see that the graph approaches positive infinity. So technically this would be positive. Okay? If you want to write like that. Well, actually I take that back because on the other side, it goes to negative.
Yeah. Only for cosecant, you could do that.
Yeah. If you use the same period that they suggest in the textbook, which we should, right? Then yeah. But I mean that's if you can do if you want to do that, that's fine. But I would just do plus or minus infinity so that you don't have to even think about it, you know?
All right, thank you.
Yeah, but it's up to you. All right, guys, I'll see you all tomorrow. I gotta teach my in-person class. All right, have a great day.